Hi, welcome to AMS Talks. I'm your special guest host, Nadia Abboud, and today I have the pleasure of sitting down with Dr. Vladimir Dozortsev, Senior Product Manager at AMS. Vlad, congratulations on receiving the 2025 AWWA Water Science and Research Best Paper Award. We're so happy to be able to sit down with you today. Could you share a little bit more about some of the core technologies or insights that led to the receiving of this award?
Thank you, Nadia. Thanks a lot. Yes, of course. We start working with City of Alamosa a few years ago, based on the interest in improving quality of the arsenic removal water system and water treatment system. And then we proposed to replace the bulk ferric reagent with in-situ generated ferric reagent on demand by our Safeguard H2O generation system. And benefits which we believed we can offer was in producing reagent on demand without any risk of storing highly corrosive and problematic ferric reagent, ferric chloride, and obviously improving quality of the reagent by using certified precursors in our system versus quite unpredictable sometimes quality of bulk ferric reagents. So what this study demonstrated that Safeguard H2O real-time reagent generation system was highly effective in controlling process very tightly, which led to quite significant reduction of arsenic in effluent below 5 ppb, and also reducing co-contaminants in the effluent, such as manganese, due to highly controllable conditions and much purer precursors which we use in our system.
So for any of our viewers who are unfamiliar with the process and how Safeguard H2O is generating, whether it be ferrous, ferrate, or stannous on site, could you share a brief overview on how the technology works and what sets it apart?
Yes, the technology is based on electrolytic approach where metal precursors like steel or tin metal, depending on application, is electrolyzed in flow through electrolytic device and produced reagent re-injected into the treatment process and used as coagulant or reducer or oxidizer, depending on application. And advantage of this approach is obviously in ability to produce reagent on demand without any storage or reagent delivery, which can be problematic. It reduces carbon footprint oftentimes because we don't need to haul reagents and its byproducts from the site or into the site. And most importantly, it's highly automated way to produce a reagent and implement it. So we can, in this case, we can definitely demonstrate step up in system controllability and accuracy.
And then how do you ensure the reliability of the performance? Are there any unique aspects to how the technology works?
Absolutely. Our system not only produces reagent on demand, which is again a very controllable process, but we also have ability to monitor quality of the treatment by monitoring both influent and effluent pretty much in real time, which gives us a very significant advantage over traditional systems which rely on manual grab samples and laboratory analysis, which can be several days or even weeks away. And then we can control process in real time. We can optimize reagent dose to levels where we need to achieve our treatment goals. And this is pretty much unparalleled advantage in modern industry today.
Vlad, you alluded to some of the environmental benefits of the technology earlier when you mentioned reduction of carbon footprint. Could you expand on that a little bit more and give our viewers some insights as to what else they can expect with Safeguard H2O?
Yes, absolutely. Traditional use of bulk reagents, which is very common in industry, associated with hauling reagent to the site, its storage, and logistics, which sometimes may be quite intensive, and then it definitely produces very high carbon footprint. On the contrary, our approach is based on generation reagent on demand at site, which saves a lot of storage capacity, and obviously bulk reagents to produce them at first place also take a lot of carbon footprint because it's quite heavy chemistry. But not only reagent generation, also reagent dose control saves a lot of carbon footprint potentially because our approach is highly economical in reagent doses, and then it produces much low amounts of byproducts, which also needs to be treated and handled. So if you look on everything combined, our approach can demonstrate very high savings in carbon footprint up to 100%.
So it's a win-win for everybody involved.
Yes, absolutely.
So where do you see this technology having the most impact? What kinds of applications are you exploring?
Yeah, that's a very interesting development. We're looking at multiple reagents today. Right now, we have in our portfolio ferrous, ferrate, and stannous reagents. Ferrous and ferric can be used for arsenic removal and organics removal. Ferrate is highly effective oxidant and can be used in very broad of applications, starting from organics removal, hydrogen sulfide removal, removal of phosphates, and many other organic and inorganic contaminants. While stannous is very strong reducing agent, which can be effectively implemented in hexavalent chromium removal, which we demonstrated multiple times. It reduces dissolved mercury highly effectively, as well as it demonstrates very strong biodegradant capacity and can be used as a disinfectant in multiple industries, including oil and gas and some others. So if you look in as a whole, Safeguard H2O approach is very universal and can be applicable to drinking, well waters, produced water in oil industry, and broad range of wastewaters.
Vlad, that is so exciting, and I'm sure our viewers can look forward to some of the demonstration reports that'll be coming out with some of these applications that you've just detailed for us. And finally, what, in your opinion, sets the Safeguard H2O technology apart from any other water treatment technology that's available right now?
In my opinion, approach which based on reagent generation on demand is definitely it's definitely having very unique benefits. It's very easy to understand that instead of hauling, storing toxic and oftentimes corrosive reagents at site is problematic, we offering very reliable and sustainable alternative. And most importantly, our approach in combination with online monitoring, online real-time monitoring of treated contaminants gives very unparalleled benefits to not only to produce reagent, but use it effectively, economically, with minimum impact on the treatment process cost and environment benefits.
That sounds like a lot of good stuff. Well, thank you so much for your insights today, Vlad. It is very clear why facilities who are looking to streamline their operations and enhance their efficiency are turning towards Safeguard H2O and the generation of specialty reagents such as stannous, ferrous, and ferrate on site. Thanks again for your time, Vlad. Great to see you again.
Thank you very much.